now we're going to practice dividing rational expressions. Since a rational expression is already a fraction, which is division, now we're dividing two things that are already being divided. So this might sound a little bit complicated at first. However, if you remember back when you divided standard fractions such as 1/2 divided by 2/3 or something like that, you simply multiply by the reciprocal. So if we're multiplying by the reciprocal, that means all we really need to do is take what we have on top, put it on the bottom, put it on the top for this second fraction here. So we just take that and we flip that, and then it's just a multiplication problem. So we're going to write that. We have our first fraction, which we keep exactly as it is. In top, throw it in parentheses. And our denominator here, our 20ab. But this time our numerator on the fraction of everything together in one expression is going to come from the denominator of this fraction. And same thing with this 6xy that was formerly in the numerator of the second part of the division expression. It's going to be in our denominator now. So once you get this flip and you put it all into one problem, it's just like solving a standard simplification problem. To do that, earlier we had a couple different ways of going about it. So one of the ways was to break this down into its factors. We go across, 3 is prime, so we'll leave that. X squared, we'll keep that. Y, 5 is prime, a squared b cubed. Just write that all out in one long string. And our denominator, 20, can be broken down a little bit. 20 is 4 times 5, or 2 times 2 times 5. So we'll get that. AB we'll leave as is. 6 is 2 times 3, and then we have this xy. So if we want to go ahead and start canceling things out to clean this up a little bit, we can see that we have a 3 up top and down below. We have a 5 up top and down below. We have x to the first power here and an x to the second, so this 2 minus 1 is 1, so we're going to just make that to the first power here. We have a y and a y. Cancel each other out. An a and an a squared, so since a squared is 1 power larger than a to the first, we're just going to reduce that to a to the first. B to the third and b, I'm going to drop the power here since this one is 1 larger than the denominator, or take it from a 3 to the second power instead. And it looks like that's all we can cancel. So on the top we're going to have xab, or well, xab squared, don't forget about that, depending on how you write your own notation. And in the denominator, 2 times 2 times 2. The other way that I like to go about getting that is trying to simplify as much as we can right from here. I see a 6 and a 3, and I see that both 3 goes into both of them, so I'm going to cross that out, and put a 2 here, because 3 divided by 3 is 1, so nothing changes. 6 divided by 3 is 2. Same thing with our 20 and our 5. I see that 5 goes into both of those, so 5 divided by 5 is just 1, so cross that out. 20 divided by 5 is 4, so I'll leave that down here. And then look to simplify my variables. I have an x squared over an x, so I'll just make that an x to the first power. A y over a y, cross those both out. An a squared over an a, so I'll make that to the first power, cross out that one. And a b cubed over a b, so I'll make that to the second power, and cross out that b. And as you can see here, our numerator, xab squared, is the same. Our denominator, instead of 2 times 2 times 2, we get 4 times 2, but we know that both of those are going to simplify down to a denominator of 8. And our numerator just stays as it is. In this next example here, same idea. The big thing that we have to remember is to flip this second part of the expression. So if we rewrite it as if we're multiplying by the reciprocal, that 1 minus k that was formerly in the denominator here is going to slide on up, and the k squared minus 4k plus 3 is going to go down to our denominator. Now all of this is under one fraction bar. Numerator, everything is multiplied together. Denominator, everything is multiplied together. And now we look to simplify from there. When I first look at this, it looks like there's actually nothing in common between the top and bottom. However, since I see squared terms, that means there's probably some factoring that can still be done. So let's get to work. When I look at my 1 minus k squared, again, that sounds like a difference of squares. And I will write this as 1 squared minus k squared, if that helps to think about it. We're going to have our k minus 3, because that's not going to change. And then difference of squares goes into 1 minus k and 1 plus k. That's something that is just worth memorizing. But if you're not sure, you can just try to FOIL it out and see that you get a 1, your minus k and plus k cancels out, and then a minus k squared at the end, just like we started with. In our denominator, that k plus 1 that we started with, nothing we can do to that. That's as simple as it's going to get. K squared minus 4k plus 3. If we want to see how to factor that down, we're looking for two things that multiply to 3 and add up to negative 4. Let's try negative 1 and negative 3. And multiply is going to be positive 3, add is going to be negative 4, so that's exactly what we need. So we'll have a k minus 1 and a k minus 3 as our two factors in the denominator. Looks like we have a k1 minus, ooh, that's not even in common at all. We have k minus 3 in common in both, but nothing else. K plus 1 and 1 plus k, they look like they're pretty much the same thing. If you remember from one of the previous lessons, the 1 minus k and k minus 1 are really similar, but we need to make sure we turn one of those around. And in order to do that, you can multiply the inside by negative 1, which will flip the order of these. But you also have to throw a negative 1 on the outside to undo what you just did. So let's see what that looks like when it's all done. What I did is I took this 1 minus k and I flipped it by multiplying the inside by negative 1. 1 times negative 1 is negative 1. Negative k times negative 1 is k. So we have k minus 1 here. But to undo that operation so I don't change the actual expression, I had to put that negative 1 out front. Always remember to do that whenever you flip something. And now it looks like I got a whole bunch of things in common. So let's start simplifying this down. A k minus 3 and a k minus 3, those will cross out. With k plus 1. What I did here, I switched the order of these because it's addition. I didn't actually change anything. 1 plus k and k plus 1 are the same, remember. So k plus 1 and k plus 1 are going to cancel out nicely. And k minus 1 and k minus 1 are going to cancel out. And I'm left with only that negative 1 that I added. So that will be my final answer. Negative 1. So two last examples here. This time the division problems are written a little bit different. They're written as a fraction inside of a bigger fraction. But remember, that's just division. It's just this divided by this second piece. And if we're doing that, all we need to do is flip the second fraction and multiply. So let's go ahead and confirm where all this stuff came from. Our x squared was in our numerator on the top one. It stays in our numerator on the bottom one. Same thing with our 9x squared minus 4y squared. Started in the denominator up here, stays in the denominator because it was part of that first fraction. The second fraction, the thing that it's being divided by, we have an x cubed in the numerator. We flip this because we're finding the reciprocal, and that's going to end up in our denominator now. Finally, our 2y minus 3x here, that was in our denominator of our second fraction. Now it's in our numerator. So all we're doing is we're taking the second fraction, we're flipping it, and then we're multiplying them together. And that's going to give us an expression that we can work from. To go ahead and take this to the next step now, to simplify this out, we need to find our common factors. Looks like we have some x's in common, but this here could be simplified further. We see x and y squared terms, and there's a difference here. There's two terms, and there's a difference. 9x squared, square root of that is 3x. 4y squared, square root of that is 2y, so we have a difference of squares here. So in our numerator, or in our denominator, excuse me, this could simplify down to 3x minus 2y and 3x plus 2y. So, show you that right here. I'll go ahead and highlight that to make sure you know where that came from. That came from this term right here. It's just a difference of squares. 3x minus 2y, 3x plus 2y. Our x cubes stay the same because nothing changed there. And in our numerator, there's nothing we could simplify, so that simply stayed exactly as it was also. Now, is there anything we can cancel out? We have our x's in common, so we have that. 2y minus 3x, 3x minus 2y, one of those flip situations, so we need to apply that -1 rule and flip one of those so that it's facing the right direction. So I arbitrarily chose the top. You could choose the bottom and it won't make any difference. But highlight what we changed. We had a 2y minus 3x, and we flipped it to 3x minus 2y and applied a -1 up front to make sure that we undid what we did inside the parentheses. Now we have something that will simplify very nicely, because we have a 3x minus 2y on both the top and bottom. We have x cubed and x squared, so there's one more x in the denominator. So I'm going to simplify that power down to 1. And -1 and the 3x plus 2y is not going to cancel, so we will just leave it as is. And in our final answer, numerator has a -1, denominator has 3x plus 2y, all times x. And that's our solution. Last one here. X minus 3 over x plus 2. All of this divided by x squared minus 9 over x squared plus 5x plus 6. Since we're just flipping this last one and doing multiplication, let's write that out and make sure that everything came from where we expected it to. X minus 3 was in our numerator. It was part of the first fraction, stays in the numerator. X plus 2 was in the denominator in the first fraction, stays in the denominator. X squared minus 9 in the numerator of the second fraction. Since we're dividing here, that's going to get flipped to the denominator. And x squared plus 5x plus 6 is going to end up in our numerator because it was in the denominator of our second fraction. So let's go on and keep simplifying here. Nothing immediately can be canceled out, but I see squared terms, which means further factoring may be possible. It's not guaranteed to be possible, but it's worth trying. On the numerator, I see x squared plus 5x plus 6. What that is going to factor into, I need to find two numbers that add up to 6, or multiply to 6, add up to 5. So 1 times 6, not going to work. 2 times 3, it's going to multiply to 6 and add to positive 5, so that's exactly what I want. So I'm going to have an x plus 2 and an x plus 3 in my numerator, along with the original x minus 3 I started with. Just highlight that to make sure you know where that came from. In our denominator, we have an x plus 2. It's not going to simplify any further. And as x squared minus 9, difference of squares, we know difference of squares in this case is going to be x plus 3, x minus 3, because we're going to have our x squared up front, our -9 at the end, and our middle terms will cancel each other out. I'll highlight that too, just so you can keep track of that. And then finally, this is our chance to cross out things that are in common in our numerator and denominator. So I see an x minus 3, x minus 3. x plus 2, x plus 2. Oh, look at this. Is that beautiful? We've seen something that looks like this problem before in one of the previous sections for multiplication. And once again, the answer is going to simply be 1. And that's dividing polynomials.